Hello everyone, this is Madhu Sirikonda, Assistant Professor, St. Peter's Engineering College and of Mechanical Engineering Department. I am taking refrigeration and air conditioning subject according to JNTUH, and this is the Unit 1, Introduction to Refrigeration and Vapor Compression Refrigeration System, a simple vapor compression VCR system. In this we have a little introduction. Refrigeration is maintaining a system, a room temperature or any place temperature less than the surroundings atmospheric temperature, below surroundings temperature, to provide cooling effect inside a system is known as refrigeration. And here it is written same. Refrigeration may be defined as the process of changing temperature below that of the surroundings and being to cool temperature. Important applications of refrigeration by storing. Refrigeration systems are also used extensively for providing thermal comfort to human or to human perishable food products by storing them at low temperatures. Refrigeration systems are also used extensively for providing comfort to human beings by means of air conditioning. In air conditioning, we need to maintain the temperature, human comfort temperature, and humidity. It is around 52%, and the temperature it is 20 to degrees Celsius. It varies depending on the comfort nature and requirements. Air conditioning refers to the movement of air so as to simultaneously control its temperature, moisture content, circulation, and by occupants or products in the space. The subject of refrigeration and air has evolved out of human need for food and comfort. History date back to in previous days. How the refrigeration was done is found a source which is cool, and cooled source, say liquid, cool water, in that cool the food items to main cool. They use direct systems. But improvements they developed refrigerators that we are using now. Refrigeration also defined as continued extraction of heat from a body which is kept at the surroundings temperature. Of course, it's a heat transfer. And now coming to thermodynamics laws. First law of thermodynamics says that when a closed system undergoes the net heat transfer is equal to the net work transfer. Cyclic integral transfer, that is del Q, is equal to integral of del W, work transfer. Well, the energy can neither be created nor be destroyed. It can be transferred from one form or to the another form. That is the first law. We need to remember this thermodynamic class. Next, second law of thermodynamics. There are two statements given by one is given Planck, and we call it as Kelvin Planck statement, and other is statement. All the statements seems to be same, but a slight difference is there. Kelvin states it is impossible to construct a device that operates in a cycle and product other than to receive heat from a single it into equivalent amount of work. It means it is impossible to construct an engine. Sole purpose is to convert all amount of input, that is heat, equal amount of work. 100% efficiency of an engine is not possible. Definitely there will be the losses or ejections of heat. Next class statement, it states that to flow from a body at a lower temperature to a body at a temperature without any external energy. Just like water will not flow from low unless we use a pump. In the same way, it cannot move from a lower temperature to higher temperature unless we, in order to carry that, he require some, we call them as heat pumps. And some important terms, it is when heat and the temperatures rise as the heat is added, the increased in it is, take any substance you take and you start heating it, just that substance changes from solid to or liquid to vapor, just reaching the saturation of heat transfer takes place, that is sensible heat, and the latent heat is heat transfer to a system phase change. Say water is changing its phase from liquid vapor phase at 100 degrees Celsius. At 100 degrees Celsius, it is phase from liquid. After reaching 100 degrees, we need to supply some amount of degrees Celsius is a saturation liquid as well as saturation. So for complete, we need to supply some heat. That amount of heat, constant temperature, and is called as latent. And here it is given. The latent heat of ice is 335 kilos per kg. It means 1 kg of kilojoules of heat at 0 degrees Celsius and atmospheric pressure. Atmospheric, this heat is called as latent. Is the water, which is ice, liquid water, uh, given to ice to liquid, degrees Celsius and atmospheric. And here some examples are given. Rise the temperature of 1 Kelvin of unit mass of some specific heat. The mountains 1 degree unit per kg Kelvin in kilojoules per kg Kelvin. So water of heat required to rise by 1 degree Celsius of a unit mass. and steam 2.094, air it is 1. Unit of refrigeration system. Unit of ton of we call tons of TO and ton of refrigeration. It is defined as the refrigeration effect produced a uniform of 1 ton of uniform melting of 1 ton of ice 4 hours. Ton of ice 0 degrees Celsius got or the amount of 1 Celsius and 20 within during 20 hours. 1 ton is ice. Latent heat of ice is 335 kilojoules per kg. 1000 we give 335 kilojoules per 24 hours. Within 24 hours is asked. So we get in watts. 6 kilojoules per minute. Kilojoules per converting minutes into, see, it is 210 kilojoules per minute. It's all because of convert to consider that is actual practical process produce the refrigeration effect. For example, a refrigeration plant is producing 10 tons of refrigeration. 10 into 10 kilojoules per minute of refrigeration effect it is producing. So thereby we need to calculate work input, or they ask us most required to produce that much of. In achieved by is or evaporative either in winter and made to extract in natural refrigeration system will produce ice. Ice is used. That ice is used for the refrigeration effect. That is what I said before. So they produce in cold air. They transported from cold or earth. We find a different region where we always that ice, and there they use that as they may use the key system, or then that can be converted into cool can be used. So natural refrigeration. Coming to artificial refrigeration, known is very difficult and artificial refrigeration. It is generally that the history of refrigeration began in the year 1755. The Scottish professor Cullen refrigerating machine, which is in the library principle refrigeration as vapor absorption system. Apparatus described by Jacob Perkins in his patent specification of 34. He used some lever, different parts are produced here. One is a tube is passing over a cold fluid that can be seen on the right side, and similarly you have a John Perkins machine built by John, this person built it. He just shown the model. Yeah. Now reversed Carnot cycle employing a gas. Reversed Carnot cycle, a engine with Carnot engine and tools, isothermal and either heat is given to a system in isothermal process, two isothermal process, heat given to a system in one isothermal process, heat rejectors, and two reversible adiabatic processes implies one is for expansion, other is for compression. Reverse it, heat is given to a cycle, run. For work is given to a system, heat is simple. Now reverse Carnot cycle is an ideal refrigeration cycle for constant temperature, external source and heat sink. Proceed the process 1 to 2. Let us see this. Let us see this cycle. 2 is reversible. Reversible 2 to 3. Reversible heat rejection in compression. Isothermal heat rejection adiabatic 4 to 1 isothermal heat absorption 3 heat rejection. And this is a schematic diagram for Carnot refrigeration system. Simple, you have condenser, expander, and we have an evaporator. In Carnot system, turbines, they help us as a compressor. So next, condenser, heat must be removed. Chamber, you have a compressor, you have an expander, and heat rejection source in actual refrigeration, and this is Q421 by W net, Q421 421 by W net. Vapor compression refrigeration system, VCR. Schematic of a refrigeration system. In vapor compression refrigeration system, compressor, condenser, expand and an in evaporator refrigeration effect, compressor, current and rise. It will keep the system. It acts as heart of a human body, and it is compressor is the heart of the VCR system. And this is TS graph is shown here, temperature versus entropy of a pure substance. If it is water, you have condensation 3 to 4 evaporation. Isentropic compression of vapor in compressor, baric heat rejection rate 4, expansion of liquid in expansion process 4, 1 extraction in the evaporator. Now let us see, the pH graph is also important. Actually, pH analysis, standard vapor compression refrigeration, VCR. We have evaporator. Evaporator is a place where we get refrigeration effect. QE evaporator is equal to minus H4. Compressor is a place where the gas, the outlet of evaporator, the refrigerant gas is compressed to high pressure. And the notable thing is work. Next, condenser function is to reject heat absorbed in evaporator. In condenser, that heat rejected. Expansion device. Expansion device for the isenthalpic expansion process. The kinetic energy change across the expansion device could be, if we take the control volume device, then the kinetic energy gap x and equals to H4. And that's it. Expansion device, the function of expansion device is to reduce the pressure, will get liquefied. Refrigerant will get liquefied, and thereby we complete this first unit. It has only this much, and along with this, if you can solve 2 or 3 problems, then this is sufficient.